Okay, third period. Welcome back from break. I hope you all had a great winter. Actually, it's still winter, but a good Christmas and a good New Year. I am coming to you live from my dining room. It's live for me. It's not live for you now. So anyway, I wanted to get us started. We only have 2 weeks left, less than 2 weeks actually, before the final exam. So let's talk about some things that are coming up. You have your geometry construction project coming up, so you want to take a look at that. Make sure that you are going through and you are choosing 4 of these designs. It can be any of the 48 different options, any 4 of those. Practice those at home because you're going to be constructing these in class on Monday. I'll give you a blank sheet of paper. You have your compass and your straight edge, and you will be constructing those. And then also be working on your window tracery design. That one you're doing at home, and then you'll bring in and turn that in along with the 4 that you will have constructed in class. I will be around on Monday. You feel free to email me. I will do my best to email you back while I'm away this week. But anyway, make sure you carefully read through the rubric. All of these things here. This is how I will be grading it. So if you want to have full credit or close to full credit, make sure that you are following these instructions to the T. And then here's just some little tips on the back of the front page, how to kind of get started and some just recommendations to maybe make your life a little easier. Okay, so that's your geometry construction project. You will have a quiz on Wednesday, on Wednesday over sections 5.2 and 5.3, and I will remind you at the end of this video as well about those as well, and then also start locating your chapter tests. So I'll remind you again at the end of the video. So let's go and review what we talked about before we left for break. So we were in section 5.2, and we were talking about the different types of angles when you've got 2 lines, and remember we label them with lowercase cursive letters, and they are cut by a transversal. Remember, a transversal crosses the lines in 2 distinct points, not in the same point. And we had said that the lines, let's see, I think it was if alternate interior angles, oh, my grandfather clock's gonna chime here. It's 15 past, so hopefully we won't get too many more of those. Okay, so if alternate interior angles are congruent, then the lines are parallel. Remember that one? All right. So there is 1, 2, 3, 4 other statements like this one. So this one says, if alternate interior angles are congruent, the lines are parallel. The next one would be if, you can probably fill in the blank, if alternate exterior angles are congruent, the lines are parallel. And you may or may not need to rewrite this. You might just be reading through your notes from 5.2, and that's fine. Just want to review though and refresh your mind because this is going to apply to what we're doing today. And then we also have if corresponding angles are congruent, then the lines are parallel. And then there were 2 that we didn't spend a ton of time talking about, but we have if same side interior angles are, now they're not going to be congruent, so same side interior, remember those are the angles, they're on the same side of the transversal, but on the interior they form a C like that. So if the same side interior angles are supplementary. Supplementary, that's supposed to say supplementary. You get it. Then the lines are parallel. And the last one is if same side exterior angles are, now are these guys going to be congruent? Let's look. Same side exterior, so I'll pull them off of the side over here. So there's this one and this one. My marker's kind of dead. Oh, I should probably get rid of this one. So those are same side exterior. They don't look congruent. So if they are supplementary, then the lines are parallel. Alrighty, so that's just a little review of what we talked about in 5.2. You've got your homework from 5.2, or not homework, but classwork, pardon me. Did I make your heart stop for a minute? Classwork from 5.2. We looked at the fat hog problem. Everybody have that one kind of handy? You don't know what I'm talking about? That's okay. We had this picture where this triangle was fat and this triangle was hog. And you were given that angle FAT is congruent to angle HOG. And you had to prove that AT, the line AT, is parallel to the line GO. Remember that one? So we have FAT is congruent to HOG. And we had to prove that these lines here are parallel, and that the part that was tricky was that we didn't see the parallel lines very well because we needed to extend them. So now we've got our parallel lines, and here is the transversal. So these angles here are going to be alternate exteriors. So we are given blah, blah, blah. I'm handwriting it. I hope it's okay. We are given that FAT is congruent to HOG, thus AT is parallel to GO since alternate exterior angles are congruent. There we go. So that was one of the problems that we did on, I think that was Thursday. Yeah, that must have been Thursday before we left for break. So that was an example or a problem. And then we also did another one. You guys kind of liked these, I think. So we had this picture of a triangle with a line inside of it. This is triangle ACD, and we have these other points here. And then you're given that angle D is congruent to angle ABE. BE is not parallel to CD. And you're going to prove that AC is not congruent to AD. So this was what we called an indirect proof. I think y'all liked doing these because they were kind of fun. And so you are given, and I'm going to write the full given because it's going to enter into the way we prove. So we are given angle D is congruent to angle ABE, and BE is not parallel to CD. So when we did these indirect proofs, remember we had to assume something. So in this case, we're going to assume that AC is congruent to AD. All right, I'm going to mark my picture. Angle D is congruent to angle ABE. These guys are not parallel. And then we have the assumption that AC is congruent to AD. Alrighty, so taking a look at our triangle, if these two sides are congruent, then we can say by proposition 5, so by prop 5, angle C is congruent to angle D. And I mark that. And then we have a little axiom 1 action going on. Thus, angle C is congruent to angle ABE by axiom 1. Alrighty. All right, so since, all right, let's take a look real quick. ABE and angle C. So you notice what kind of angles those are? They form that upside down F, or the F shape. So that would make them the corresponding angle. So since corresponding angles are congruent, lines are lines plural, lines are parallel, making BE parallel to CD. But BE is not parallel to CD from the given. I'm being a little fancy right there. Therefore, AC is not congruent to AD. All right, so there's our indirect proof. So we are given, we have to state the assumption, so that was an important piece. I've got all kinds of colors at my disposal when I'm at home like this. So we have, that's our assumption, that's an important piece there, right? And then we go through and we show that, actually, that something here, so this piece here, is counter to what the given is, right? So we proved something that was not true, so thus that means my assumption is false. Alrighty, so those were our two big ideas before we left for the break. So let's move on to things that, actually, oh, you know what? Let's do one other thing. Sorry. I wanted to show you an algebraic problem using these ideas. So let's go ahead and do an example. And we'll set it up. It looks like so. We've got two lines here and a transversal. And we'll call this line M and this line N. And this angle here is x squared plus 10. And this angle here is 3x plus 17. So this is, the way the problem is going to work will help you with your review too for your final, because there's a little bit of algebra to this problem that, that may or may not show up on your final. And the question is, what value or values of x would allow you to prove M parallel to N? So what values of x would allow you to prove M, the line M, is parallel to the line N? So if we look at these two angles, I'm going to trace them. You probably already know what they are, but I'll trace them anyway. So there's the x squared plus 10 angle. Here is the 3x plus 17 angle. And oh, there's the F. So we know they're corresponding. So if we wanted to say that M and N were parallel, the correspondings would need to be congruent, which means we've got to set these two guys equal to each other. So x squared plus 10 equals 3x plus 17. The algebra is over. We just finished the geometry is over. We just finished the geometry part. We're going to move into an algebra portion. And you notice you have a quadratic term and a linear term. Whenever that happens, we have to set it equal to 0. So move all of your terms over to one side. I like to keep my x squared positive. So x squared minus 3x, subtract the 17, that gives us a minus 7 equals 0. And then we try and factor factors of negative 7 that add to equal negative 3. Well, not so much because 7's prime. So plan B, we've got to use the quadratic formula. So this might also be an opportunity for you to remember the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Remember that catechism from last year? We said it every single day. Here we go. X equals, so negative b, so that would be a positive 3, plus or minus the square root of negative 3 squared is a 9, minus 4 times a, which is 1, and c is negative 7. All over 2, and then a is 1, so I'll just leave it as a 2. Okay, here we go, equals 3 plus or minus. You guys are all brainiacs. A lot of you can do this faster in your head than I can. So this will be 9 plus 28 divided by 2, which equals 3 plus or minus the square root of 9 plus 28 is a 37, divide by 2. And 37 is a lovely irrational, square root of 37 is a lovely irrational number. So x, get out your calculators. X is going to be, if we take this, finding the square root of 37, we're going to round that to about 6.08. So we have x equals 3 plus or minus 6.08 divided by 2. And that will give us 2 possible answers that we're going to have to check. So x is about 4.54 and x is about negative 1.54. And we check them both. And when you plug 4.54 in, well, that's going to be a positive, yeah, that's going to work because you don't have to deal with any negative issues. So this one definitely will work. The negative 1.54 is a little bit of a question mark for me, so I plug that in, and that gives me, let's see, that'll be a negative plus that, that'll be a positive plus that. So it looks like they're both going to be about 12.8, 12.3, 12.4. So this one works also. So you have 2 possible solutions for that. So I just want to give you a little bit of a review of some algebra that is incorporated into the geometry. So hopefully that will help you out with your final review as well. Okay, new notes. Are you ready? Or do you need to go get some paper? I'll give you a second. I have a little helper that's on top of the table with me right now. Oh, here goes the grandfather clock. It is 1/2 the hour. Okay, so the cat's on the table too. I apologize if he gets in the middle of things. You know how cats are. Okay, we're on 5.3, and we are talking about congruent angles. Congruent angles with, here's a big word, associated with associated parallel lines. Okay, so let's look at our typical picture here. 2 lines cut by a transversal. And we'll call this line A, and this is line B. And we're going to make 5 statements. So they're going to be very similar in sounding to the 5 statements from the review. Very similar. Really similar. They're going to start off, all 5 of them are going to start off the same. They're going to say, if A is parallel to B, then. And I'm going to do an ellipse. Okay, so if A is parallel to B, then, sorry, it's so much easier for me to write cursive with a ballpoint pen, but I'm trying not to. So I apologize if I slip into it. Plus we have to do cursive for the lines, so that confuses my hand too. Okay, if A is parallel to B, then, here we go. Our first statement, then alternate interior angles are congruent. So notice this is just reversing the order of the premise and the conclusion from the review. So before we said, well, if alternate interior angles are congruent, then the lines are parallel. This time we're saying, if the lines are parallel, then alternate interior angles are congruent. I'm sure you can figure out the other 4 conclusions. Alternate exterior angles are congruent. Corresponding angles are congruent. Okay, those are the 3 congruent statements. Next, we're going to slip into the other 2. So same side, we'll do interior angles. Interior angles are not congruent, but supplementary. And then the last one, same side exterior angles are supplementary. Okay, so let's utilize those. Let's do an example. Need a little picture here. And we'll do A, B, C, D, E, F. The given is FA is parallel to DE, FA is congruent to DE, and AB is congruent to CD. So those 3 pieces of information are given to you. You're going to prove angle F is congruent to angle E. Pretty short, pretty straightforward. I think you could probably do it without my help, but it's our first example. So let's mark everything. FA is parallel. Remember how to mark parallel lines. We use those little arrows, right? So FA is parallel to DE. FA is congruent to DE. I always, if it's congruent, I do a different tick marking than the parallel, because parallel does not mean congruent. They're 2 different things. You can have parallel lines that are not congruent. And then AB is congruent to CD. I need to prove F is congruent to E. And there's no indication that FC and BE are parallel, and F and E don't even share a transversal. So I'm thinking we're going to have to go the path of congruent triangles. So let's get going on that. So we are given, and I'll just do the ellipse there because we're given a lot of information. All right, so far, if I'm going to prove these 2 triangles are congruent, I have a set of sides congruent. I could probably come up with another set of sides, right? I can do AC is congruent to BD by adding the piece BC using axiom 2. So we can say by axiom 2, AC is congruent to BD. So that gives us another S. And then we've got parallel lines. I'm going to color shade this a little bit. We've got parallel lines here, and then we've got a transversal. Notice AD is a nice transversal through these 2 parallel lines. So if I trace here, I've got a lovely Z. Do you see that? All right, so if lines are parallel, then, all right, we'll use our little notes up here, then, and in this case, the alternate interior angles are what we want, then alt int angles, oops, weird, sorry, angles congruent, so angle A is congruent to angle D. Now we have enough information for our triangles, thus triangle FAC is congruent to triangle EDB by SAS. Therefore, angle F is congruent to angle E by CPCTC. Yay? Easy, right? But helpful. All right, the next example is one of my favorite types of problems. But first, we're going to talk about something that's kind of controversial because it's hard to prove. Euclid used this as one of his postulates. It's called the parallel postulate. But it was very controversial because it wasn't intuitive. All right, the parallel postulate says through a point not on a line, not on the line, through a point not on the line. So obviously there's some given line because it's a definite article. So through a point not on the line, there is exactly one parallel to the given line. So that means if I have a line and a point that is not on the line, doesn't matter where, as long as it's not on the line. So I'm going to put mine right there. There is only one parallel that will go through this point and is parallel to this line. That's it. There's only one. If I drew the line any differently through the point, it wouldn't be parallel, right? So there's only one line that is parallel to this given line through that given point. Okay, keep this in mind in the back of your brain. We're going to use this. This is going to be something that we will apply. These are going to be called Crook problems. Crook problems. Now, there's no stealing involved in this. No harming in the process of doing this. But a crook problem looks like a crook. So when you have your arm bent at your elbow, you have a crook in your arm. So let's draw a set of lines here, set of parallel lines. And we'll call them A and B. And then I'm going to draw in a crook. So it's a straight line bent. So imagine this is an elbow here. This is the crook of your elbow, where your elbow bends. And it is given that this angle here is 100 degrees, and this angle down here is 40 degrees. And your job is to solve for angle 1. So find the measure of angle 1. That's going to be the job. And you look at it and you think, well, I have no idea how to do this. I don't have any information that's helpful to me. I can't draw in triangles because that's arbitrary. So using the parallel postulate, we can set this problem up in a way that makes this a very easy to solve problem. So here's our line, our given line is A, for instance. and we're going to, we know that A is parallel to B. So A is parallel to B. That would be a given piece of information. A is parallel to B. I'll draw in my little arrows there. Got a lot of arrows. So A is parallel to B. So I'm going to draw in a line parallel to A, which would also be parallel to B, going through this point here where angle 1 is located, the vertex. So drawing in a line that is parallel to A through the given point. It would also be parallel to B. Now I've got a situation that I'm familiar with because I can trace angle 100 degrees, and then this part of angle 1. See that part of angle 1? So this line is not, this parallel line that we just drew, it is not cutting angle 1 in half. Let's be clear, people. It is not cutting this in half. We got that? Make a note to yourself if you tend to do these kinds of silly things. This line is not cutting this angle in half. It is parallel. That is all. When we trace the 100 degrees and then this part of angle 1, the relationship between these two, they are same side interior. So these are supplementary angles. So we know that this will be 80 degrees up here. Let's do the same thing with angle 40. So I trace angle 40 degrees, and then I trace the other part of angle 1 that I don't know yet. And those form the letter Z, which means they are alternate interior. So that makes this 40 degrees. So angle 1 is equal to, part of it is 80, and part of it is 40. So angle 1's measure is 120. I love the simplicity of this problem. It is so beautiful. Draw a parallel and suddenly your relationships, your angle relationships, help you to solve the problem easily. So that's called a Crook problem. And you'll have at least one of those on your homework tonight. All right, your assignment for this evening and the weekend is page, let's see, I'm in the wrong month on my planner here. We're in January now, hard to believe. I hope you all had a good new year. It's always such a nice, fresh feeling that you're starting off with. Okay, we are on page 229, and you're gonna work problems 1 through 10, 14 through 22, and number 27, okay? So those are that's your homework assignment for the weekend. And you have plenty of time in class to work on that. My clock is going to tell me it's about 1/4 till, which would mean we've only been at this for 30 minutes or so. Here we go. There we go. Okay, reminders, things that you need to do. Remember, you have your construction project. You have your construction project on Monday Monday. And that's the 8th. That's reminder number 1. Reminder number 2. You have a quiz. You will have a quiz over 5-2 and 5-3 on Wednesday. That'll be the 10th. And then your last reminder is to locate your old chapter tests. Because once your quiz is done on Wednesday, we're gonna review. So you're gonna wanna have the old stuff handy. I think you're gonna laugh at yourself when you go back and you find your old chapter tests and you look at your mistakes, You have come so far, and you're thinking that you might just laugh at what a silly Billy you were back in September and October. Okay, so be good for the rest of the class period. I will see you on Monday. You can I recommend working on homework and or working on your construction project, figuring out which of those four pictures you want to pick to do in class on Monday. So you've got stuff. Now you all know where the compasses are kept and where the straight edges are kept. As long as you take good care of my things, you are welcome to borrow them and be nice to one another and considerate of one another. Alrighty? I will see you Monday. Be good. And let me see if I can shut this off with some finesse.